Hello everyone. In the previous video I have discussed about the AVL trees with you. Okay. Now in this video we will see the AVL tree insertion. Okay. Now see, in the previous video what I have told you is that there are certain types of rotation involved in your AVL trees. Okay, so we are having LL problem, RR problem, LR problem and RL problem, and for that I have told you what are the rotation involved. Okay, so that in detail we will see in this example. Okay, while inserting the nodes in your AVL tree. Fine. Okay, so see, these are the nodes given to you, and in this order you have to insert the nodes in your AVL tree. Fine. Now see, though your first node is 15. Okay, so 15 is your root node, so we will insert it first. Okay, now see, what we have to keep in mind for AVL tree is that our tree should be balanced. Okay, so and for that what we have our balance factor. So at each and every step we have to find the balance factor for each and every node which is inserted to check that our tree is balanced or not. Okay, fine. And you already know that balance factor should be in the range of our either 0, -1 or 1. Okay, so your balance factor should be either of these value, then only your tree will be balanced. Okay, and if the balance factor of any node is not within this range, then you have to balance your tree. Okay, so see, first of all, when we have inserted this node 15, so now what is the balance factor for this node? Balance factor for any node is your height of left subtree minus height of right subtree. So height of left subtree minus height of right subtree will be your 0, 0 minus 0, because it does not have any children. So balance factor for this node is your 0 at this time. So this tree is your balance now. Okay, now when we will insert the node 18. Okay, now where 18 will come? See, 18 is greater than your 15, so 18 will come on the right of 15. Fine. And this you already know that AVL tree is your binary search tree. Okay, and it is a height balance binary search tree. So binary search tree, all the which we have followed in binary search tree, that we will follow here, that left subtree is smaller than your root node, and then root node is your smaller than right subtree. Okay, now see, 18 has come. Now again what we have to do, we have to again find the balance factor for each and every node to check whether our tree is balanced or not at this present moment. Okay, now see, balance factor for 18 will be your height of left subtree minus height of right subtree. So it is your leaf node, so height of left subtree minus right subtree will be your 0. Fine. And now for balance factor for this will be changed. So balance factor for this node will be height of left subtree, that is your 0 minus 1. So 0 minus 1 is your minus 1. Fine. Again your tree is balanced because both the balance factor are within this range. Fine. Now we have to insert the node 12. Okay, third node your 12. Now see, 12 is your smaller than 15, so it will come where? To the left of 15. So your 12 will come to the left of 15. Fine. Again what we have to do, as we are inserting a node, again we have to find the balance factor for each and every node. Fine. Now see, balance factor for this will be 0 only. This is your leaf node, height of left subtree minus height of right subtree. For this one again, height of left subtree minus height of right subtree will be your 0. And for this node now balance factor is your height of left subtree minus height of right subtree, that is 0 minus 0 is your 0. Fine. This is also your 0. Now again your tree is balanced. Okay, now we will insert the node 20. Okay, next node 20. Now where 20 will come? See, 20 is greater than 15, so it will come to the right of 15. So it will come to the right of 15, it will come here. Now again 20 is here greater than 18, so it will come to the right of 18. So again your 20 will come here. Fine. Now again what you will do, you will find the balance factor after insertion of every node. So see, again balance factor for this will be 0 minus 0, 0. It is your leaf node. For this will be 0 minus 1 is your minus 1. For this will be leaf node 0, and for this node will be 1 minus 2 is your minus 1. Again your tree is balanced now. Okay, all the balance factor are within your range. Okay, now we will insert the next node 23. So now where 23 will come? See, 23, it is greater than 15, so it will come to the right of 15. Again it is greater than 18, so it will come to the right of 18. Again it is greater than 20, so it will come to the right of 20. Okay, so 23 will come on the right of 20. Fine. Now see, again what we have to do, again we have to find the balance factor for each and every node. Okay. Now see, balance factor for this 23, what is the balance factor for this 23? It is your leaf node, it will be 0. For this 20, 0 minus 1 is your minus 1. And for this 18, 0 minus 2 is your minus 2. Now what you have noticed there, see, again this balance factor is not our within this balance factor range, means now here your tree is not balanced, and that is because of this particular node, because balance factor of this node is not your within this range. Fine. Now what you have to do is you have to make rotation to make the tree balance. So first of all we'll see, so this, because of this node your tree is not balanced. So what I have told you in the previous video, what we will check here, see, these all are because of this right. Okay, this particular node is not balanced because all the nodes were inserted in right. So what we have to do, we have to write right. Okay, now right. For these three nodes we have to perform your left rotation. Okay, this is a simple RR problem and you have to perform a left rotation on it. Okay, so you have to perform left rotation on this three nodes. Okay, so what you will do in any problem, see, whatever the nodes are there, you will take them as a separate node, then perform rotation on it, and then you will stuck on your tree. Okay, so see, we have the problem in this particular, these three nodes, problem was because of this, and this was RR problem, so we will take this aside. Okay, we'll take this aside and perform a rotation on it, and then we will stuck it back here. Okay, so this is your 18, 20 and 23. So every time you, if you will do like this, then it will become your simply, you will not get confused in between this whole big tree that what you are doing or not. Okay, you know the problem is because of this, these three only, because of this node, and you have to perform rotations on these three nodes. So you will take them aside, perform rotation on it, and then after that you will bring it back. Okay, now see, this is your simple, what is was this is your simple RR problem, which we have already discussed. And what you have to do for RR problem, you have to perform a left rotation. When it is a RR problem, then you have to perform a left rotation. Okay, so what happens in left rotation, see what will happen if it will move to left, this 18 will come down, fine, and 20 will become your root node and 23 will come here. Okay, this was all left rotation, we have already discussed. So this will become your, after rotation these three nodes will become as like this, and now you know that this is your balance, because this is 0 0 and balance factor for this is also 0. Now what you have to do, okay, and one time you have to check also, see, 20, 18 is your less than 20 and 23 is your greater than 20, so this is your correct. Okay, now again what you will do, see, these three nodes you have performed the rotation, you will take these three nodes from here. Okay, and now what you will do, now you will stuck your this balance point, this balance node here. Okay, these three nodes were here, but now these have got balance and these will come like this here. Fine. So in this way you can take the part as separate. Okay, then you will not get confused. Now after rotation your tree has become like this. Fine. Now again what you have to do, you have to check the balance factor again for each and every node, that whether it is balanced or not. Okay, now see, balance factor for this will be 0, for this will be 0, for this will again be 0, 0 minus 0, for this will be 0 only, leaf node. Now for this it will be 1 minus 2, 1 minus 2 is your minus 1. Okay, 1 minus 2, so 1 minus 2 is your minus 1. Now you can see balance factor are within our range, so our tree is balanced now. Okay, so in this way you will do the rotation, the step where your tree got unbalanced. Fine. Now again our tree is balanced. Now we can insert our next node here. Now see, our next node is 16. Okay, now where 16 will come, see, okay, now where 16 will come, see, this is a 15, fine, this is your 12, this is your 20, 18 and your 23. Fine. Now you have to insert 16. Okay, now see where 16 will come. 16 will come where? This is your 15, so 16 is greater than your 15, so it will come to the right of 15. Now it will come here. Now 16 is your smaller than 20, so where it will come? It will come to the left of 20, so left of 20 it will come here. Now again 16 is your smaller than 18, so it will come to the left of 18, means 16 will come here. Okay, now see 16 will come here. Fine. Now 16 will come here. Now again what we have to do is we have to check whether our tree is balanced or not. Okay, now see this is your 0, this is your 0, this is your 0. Now this is your 1 minus 0 is your 1. Now this is your, what is this? 1 2, 2 minus 1 is your 1. Okay, and for this one balance factor is, this is 1, 1 minus this, right, left subtree height is 1, 1 minus right subtree height is 1 2 3, 1 minus 3 is your minus 2. Okay, and here you have to take the height which is maximum. Okay, because height of a tree is the longest part, so 1 2 3 will take this, we will not take this as the right sub height. Okay, so left subtree height is 1 minus right is 1 2 3, so 1 minus 3 is your minus 2. Now what you have seen again, minus 2, this is not your balanced tree now because of this node, because the balance factor is not within this range. Now again because of this node, our tree is not balanced. Okay, so again we will perform a rotation here. Now what rotation we have to perform? Because of this node is not balanced, so we will write this as R and this as L. Okay, because of this only it is not balanced, R and L. Now again what I have told you, the part which is not balanced, you will take it separate, make a rotation on it, and then again you will stuck it back here. Fine. Now see RL rotation. Okay, what we will do in RL rotation, first we will make it to RR rotation and then we will perform left rotation on it. Okay, so we will take this part as separate first. Okay, now see, okay, see here, see here, this is your 15. Okay, this is your 15, this is your 20, and this is your 18. Fine. Okay, only this part we will take separate and we will perform rotation. Now 15, 20 and 18. So this is your R and this is your L. So what I have told you in RL rotation, first of all we will make RL rotation to RR rotation. How? With this left we will move to make a right rotation on these two nodes first and make it as a RR rotation. So this will be your 15. After moving this will come here 18 and this will come here 20. Fine, in this way only these two nodes we will rotate to right, so it will come 18 20. Now this is your RR problem. Now for RR problem what you will do, you will make a left rotation. Now a left rotation will be your this way, so this will be your 18 and this will be your 15 and this will be your 20, this way only. Fine. Now this is your balance one. Now what you have to do is simply this place you will stuck this part. Okay, and then you will see the arrangement of other nodes with respect to it. Okay, so see this first we will write here. Okay, so this after rotation these nodes, this has become this, so first we will draw here 18, then is your 15 and then is your 20. Okay, so these nodes have become like this, these three nodes. Now we'll see the other nodes with respect to these. See, now 23 was on the right of 20, so 23 we will mark on the right of 20. Fine. Okay, now see 12 was on the left of 15, so 12 we will mark here as it is. Okay, so these, but now see this 18 on the left of 18 we were having 16, but now 18 we are having here, so where we will put this node 16? So see 16 is on the left of 18 because 16 is smaller than 18. Now see 18 here, so 18 will come, 16 will come on the left of 18, so it will come here, but here 15 is already there, so where we will insert it? Now we will check for this. So 16 is greater than 15, so it will come to the right of 15. Okay, now see 1 2 3 4 5 6, 1 2 3 4 5 6, all the nodes you have inserted now. Fine. So only what the change and what was the important thing here was, see This all we have rotated, we have put it like that. Okay, other nodes which were joined to them, we have put them like as it is. Okay, only we were having the problem with 16 because 16 was on the left of 18, but now 18 has become our root node and the two nodes are already on its left and right. So that position we have to check it at where we will put the 16 now. Okay, and we have not to left any node here. Okay, 16 we have checked with 18, so 18 is already there, but it will come on the left of 18. Now we have checked with 15, and now the position of 16 will be like this. Okay, now again what you have to do, is this your tree balance or not, you have to check now. So see, balance factor for each and every node. See, balance factor for this will be 0, for this will be 0, for this will be 0. Fine. Now for this will be 0 minus 1 is your minus 1. For this will be 0 minus 0 is your 0, and for this will be now 1 2. 2 minus 2 is your 0. Fine. Now see, the balance factor for each and every node is balanced. So it is in our this range. So until now our tree is again balanced. Now we can insert our next node. Okay, so now our next node is your 13. Fine. So next node is 13. So we will insert 13. Okay, now see where this 13 will come. Okay, here we have inserted your 16. Okay, now we'll insert the 13 on here. Insert 13. Fine. Now see where 13 will come. See, 13 is your smaller than 18, so it will come to the left of 18. Will come here. Again 13 is your smaller than 15, so it will come to the left of 15. And now this 13 is greater than your 12, so it will come on the right of 12. So where this 13 will come, this 13 will come here. Fine, this 13 will come here. Okay, so after inserting 13, our tree will become like this. Now again what we have to check, we have to check the balance factor. Okay, so again we will find the balance factor for each and every node to check whether our tree is balanced or not. Okay, now see here, the balance factor for this node will be 0. It is leaf node. For this node will be 0 minus 1 is your minus 1. For this will be 0. For this will be 0. For this node will be, see, 1, 2. 2 minus 1 is your 1. For this node will be 0 minus 1 is your minus 1. And now for this node will be 1, 2, 3. 1, 2, 3 minus 2. 3 minus 2 is your 1. Fine. 3, 1, 2, 3. This height you will take in the left subtree height. 1, 2, 3. Not this one. Okay. The longest edges path we have to take. So 3 minus 2 is your 1. Now check the balance factor for each and every node is balanced. Means our tree is balanced now. No need of any rotation. Fine. Now after 13 we have to insert the node 11. Okay. Now we'll insert the node 11. So see. Now where your 11 will come. Okay. Now see here. 11 is your smaller than 18, so it will come to the left of 18. Again it is smaller than 15, it will come to the left of 15. Now again it's 11 is your smaller than 12, so it will come to the left of 12. So your 11 will come here. Fine. Now again what we have to do? We have to find the balance factor for each and every node again. Okay. Now see balance factor for each and every node. See balance factor for this will be 0, 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 for this will be 0. Now for this will be 1, 2. 2 minus 1 is your 1. Okay. Now for this will be 0 minus 1 is your minus 1. Fine. And now for this node 1, 2, 3. 3 is your longest path. 1, 2, 3. 3 minus 2. 3 minus 2 is your 3 minus 2 is your 1. 1, 2, 3. 3 is your longest part, or 1, 2, 3. 3 minus 2 is your 1. Again your tree is balanced. So no need of any rotation again. Fine. Now see your 11 is inserted. Now we'll insert 14. Okay. Now see where this 14 will come. Okay. Now we'll check where this 14 will come. So see. Now we have to insert the node 14 here. Okay. Now we have to insert the node 14. Now again we will check where this 14 will come. See, 14 is smaller than 18. It will come to the left of 18. Again 14 is smaller than 15, so it will come to the left of 15. Now it will go here. Now 14 is greater than 12, so it will come to the right of 12. Now here 13 is there, so 14 is again greater than your 13, so it will come to the right of 13. So 14 will come on the right of 13. So your 14 will come here. Fine. Now again what we have to do, we have to calculate the balance factor for each and every node to check whether our tree is balanced or not. Fine. Now see, okay, so now see, balance factor for this node will be 0. Okay, now balance factor for this node will be 0. Again we'll see the balance factor for this node. So balance factor for this 13 will be your 0 minus 1 is your minus 1. 0 minus 1 is your minus 1. Fine. Now for this will be 0 minus 2 is your minus 2. 1 minus 2. This is your one node. 1 minus 2 is your minus 1. Fine. Now for this is leaf node, so it is 0. This is also 0. This is 0 minus 1, 0. Now for this 15C. Now balance factor for this will be height of left subtree. Height of left subtree is your 1, 2, 3. We'll take the maximum path. 3 minus 1. 3 minus 1 is your 2. So what you are seeing here, now the balance factor for this node has come 2, means this tree is not balanced again because of this node. Okay, because the balance factor for this node is 2. Now again you have to balance this node. Okay, now what we will write to balance this? See, why it is unbalanced? Because of more number of nodes in its left part. So problem is because of your this L and this R problem, LR problem. Okay, now see, you can confuse here that why we are not taking this direction, that this is L, we can take this also. See, your tree got unbalanced because of this path, because we have taken the height of this particular tree, because we have to always take the path of the tree which is the longest path. Okay, so because see, this node is having this much node in your left part, but right it is only one node. Because of that only this tree got unbalanced. So because of this path only this tree got unbalanced, so we will take this as LR problem only. Fine. After solving this problem only this tree will got balance. Okay, you can try taking this as LL problem and then solve, your tree will not get balanced because your tree got unbalanced because of this path only. This path only you have taken in your height finding the balance factor, and this only you have to take because this is the longest path and we have to take that only. Now see, this is your LR problem again. Now what you have to do again, but I told you these three nodes, this problem is because of this 15, 12, 13. This is LR problem. Okay, so now what we will do is we will take our this part as our separate part. Okay, 15, 12 and 13. We will perform rotation on it and then we will again stick it here. Fine. So we will take this 15, 12 and 13 here. So see, 15, 12 and 13 we will take here and we will perform rotation on it first. Okay, now see what we will do here. See, this is the LR problem. So this R we will rotate to its left side. Okay, so we'll first make it as a LL problem. So when we will rotate it to the left, so this 13 will go above and 12 will come down. Okay, so how your tree will be? This will be a 15, 13 will go above, so it will come here 13 and 12 will come down. Fine, this way only. Now this has become your LL problem. Now for LL problem what you will do? You will perform a right rotation. So when you will perform a right rotation, how your nodes will be? How your nodes will be when you will perform a right rotation, this 15 will go down and 13 will become your root node. So this will be your 13 and 15 has come down. This is your 15 and this is your 12. Fine. In this way only your tree will be, this will come down. Now you can check here also one time. See, 13 is your root node, 12 is less than 13 and 15 is greater than your 13. So our tree is correct only. Okay, so in this way we will perform the rotation. Now what we have to do, we have to stick this part here as it is 15, 12, 13. We have to stick this part here and we'll adjust the other nodes. Okay, so that we'll see here. Now how our tree will become. See, now see, first of all our root node is 18, that will keep as it is, that will not be affected, and the 20 and 23 also will not touch, we will keep as it is because we have not perform any rotation on it, they are as it is. Okay, so first we will write those as it is. Now see here, when we will come here, now instead of 15 what has become a root node? 13. So now 13 has become a root node and we will write this 12 and 15 as it is. Okay, this much we have got for after balancing. Now we'll see other nodes. Okay, so see, 16 is on the right of 15, so 16 will come here on the right of 15. Okay, now again see, this 11 is on the left of 12, so 11 will come here as it is. Fine. Now what is left? See, this 13 we have included. Now this 14. So 14 is on the right of 13. So, but now see here, 14 is on the right of 13, but it has already a node here. Now where will it will come? So 14 will come here then, but then we will check with this node now. So 14 is smaller than 15. So now 14 will come here on the left of 15. Okay, now your tree is balanced. Okay, so now again we will check the balance factor for each and every node to check whether it is balanced or not. Okay, now we will check again. So see, balance factor for this will be 0, this will be 0, this will be 0. Okay, for this will be 0, for this will be 0, for this will be 0 minus 1 is your minus 1. For this node will be your 1 minus 0 is your 1. For this node will be 1, 2 minus 2 is your 0. For this will be 1, 2, 3 minus 2 is your 3 minus 2 is your 1. Now the balance factor for each and every node is in our range. So this tree is our balance now. Okay, now we can insert a next node on it. Okay, so now our last node which we have to insert is your 10. Okay, now see where this 10 will come. We will check that. Okay, now where this 10 will come, see here. Now 10 is your smaller than 18, so it will come on the left of 18, so it will come here. Now when it will come here, again this 10 is smaller than 13, it will come to the left of 13. Again it is smaller than 12, it will come on the left of 12. Again it is smaller than 11, so it will come on the left of 11. So your 10 will come here. Okay, you will insert your 10 here. Okay, now after inserting, what you have to again check, is your tree balanced or not? Okay, now again for that we have to find the balance factor for each and every node. Okay, now see, balance factor for this is 0. This is your leaf node. Okay, balance factor for this will be 1 minus 0 is your 1. Okay, balance factor for this is 0, for this is 0, for this is 0. Now balance factor for this you will check. This is your 2 minus 1, 2 minus 0. So this is your 2. 2 minus 0 is your 2. Now again this tree is not balanced because of this node. Fine. So now what is the problem here? See here, all the nodes are on the left side, LL. So you have your LL problem here. Now for LL you have to perform a right rotation on these 3 nodes. Okay, again what you can do, you can pick these 3 nodes, perform a right rotation on it, and then again you will stick it here. Okay, now see here. So what after we will perform a right rotation on these 3 nodes. So you can perform here. See here it is your 12, 11 and 10. Okay, so these are on your LL. So you will perform a right rotation on it. So how it will become? See, 11 will become your root node, 10 will be your left, and 12 will come on the right. Now these 3 nodes are balanced. Now these are balanced. Now you can stick it here. Okay, now see how your final tree will become after this rotation. Again we will draw here only. Okay, now we'll draw it here again. So see what we have to do. All the other nodes we have to write as it is. Okay, so 18, that is no changes there. So 18 is your root node, that is 20, 23 is not changed. That will also you can write as it is 20, 23. Fine. Now again 13 also you can write as it is, no change in it. Okay, and this part also you can write as it is. Okay, only this part is changed, this part also you can write as it is. So this is your 15. Fine, this is your 14. Sorry, this is your 14 and this is your 16. Fine, now this much you have written. Now what you have to write here, instead of these 3 like this, 12, 11, 10, you have rotated them. So now your tree has become, these 3 nodes have become like this. So this you can stick it here. Okay, so now 11 has become your root node. So you will make this as your 11. Fine, this is your 11, then 10 and then your 12. Okay, so see why we are doing like this, because here only in the tree, if we will rotate, we will get little bit confused. Okay, with other nodes also we will get confused. So that's why we are taking the part which is unbalanced, in which we have to perform the rotation. After performing a rotation, then it will become more easy. We have to only stuck it here at that part where it was already attached. Okay, and that it will become little easy. Okay, and you will not confuse in this way. Okay, now again we have done the rotation after we are putting this 10 node in our tree. Okay, now again we have to calculate the balance factor for each and every node. So now see the balance factor, we'll check here. So for balance factor, for this is 0, for this is your 0, for this is your 0, this is again 0, this is again 0, this is 0. Now for this node 1 2, 2 minus 2 is again 0, for this 0, for this one, what is this? 0 minus 1 is your minus 1. Now for this node, height of right subtree, sorry, left subtree. So left subtree, the greatest height you will take 1 2 3, 1 2 3. So 1 2 3 is your longest height. Okay, so 1 2 3 minus 2 is your 1, 3 minus 2. Now again the balance factor for each and every node is under our balance factor range. So now your tree is balanced. Okay, so now we have inserted all the nodes. Okay, so in this way you can do your AVL tree insertion. Okay, only the thing you have to remember is, after inserting every node, you have to calculate the balance factor for each and every node, and then you have to check that it is in the range of our balance factor range or not. And if it is not in the range, then we have to perform the rotation on those particular node only where our tree is got unbalanced. Okay, so like we have got here that our tree got balanced because of this node. And why? Because all the nodes were on the left after this. So we will stuck that part here, we will perform a rotation on that part, because all the rotation we know. If it is LL, then we have to perform right rotation. If it is RR problem, then we have to perform your left rotation. If it is a RL problem, then you have to make it as RR problem, and then we have to perform left rotation. If it is a LR problem, then you have to make it LL problem and then perform a right rotation. Only those 4 problems you will get. Okay, so that part you have to stuck it separate, then perform a rotation on it, and then again you have to stuck back in your tree. Okay, in this way you will not get confused. Then again you have to find the balance factor for each and every node to check that after rotation also a tree is balanced or not. Okay, so in this way you can do the insertion in your AVL tree. Okay, so this was all about this video. Hope you understood it. Okay, now in the next video we will see the AVL tree deletion. Okay, thank you.